Everybody, just going over number 14 here from the H-dubs. We didn't have time for it, so here it is. No fancy editing, no funny business like that. Okay, so we have split it up into algebraic terms with subscripts to indicate the different parts of the trip. The first part of the trip is 1, and then, so that's 89.5 kilometers an hour. The second part of the trip where she is at rest, that's part 2, so that's 0 kilometers an hour. We're told 22 minutes, but we can't deal with it in terms of minutes because everything else is in hours, so we got to convert that to hours, so I've done that. And then we're told the average speed of the whole trip. That means when everything's put together, including the stopping time, that's what that average speed is, and that's what that line over that means. So we have a couple of things that are glaringly unknown. We don't know the time 1, that's the time that she's traveling, that 89.5, and we don't know the total time. We also don't know the distance that she travels for the entire trip, and we don't know that D1 either. So the best way to think about average velocity is total distance over total time. So that's a D1 plus a D2 and a T1 plus a T2 in the denominator. We know that D2 is equal to 0 because she's not traveling anywhere during that part of the trip. So we can get rid of that. Now, we have to make sure that we can put this in terms of things that we know and don't know. But we can only have one thing that we don't know. So what I'm going to do here is I'm going to rewrite D1 in terms of something that I know and another variable that is unknown that I'm trying to solve for, in this case T1. And then I'm going to substitute that in above. So then we know T2, we don't know T1, and we know V1, and we just have that other T1, okay? Lots of subscripts and V's and T's. I apologize. So substituting in that that V1 times T1 for D1 in the numerator, we're left with this. Now let's get rid of that little algebra. Let's move it just off to the side, all right? And then we can put our V average right here. Now, from this point on out, it is just algebra, which I'll go ahead and try to explain. I write these things down first, and then I voice over after, so I'll try to keep up as I write down. So we have this denominator here, and we need to move it to the other side. So we're going to multiply both sides by T1 plus T2, and then we're going to distribute that V average inside those parentheses, and we get these terms. So you can see here we're pretty close to actually solving this thing. And by solving this thing, I mean finding T1. The next step here is to get all the T1s on one side, which means subtracting that term V average times T1 over to the other side. Okay. Once we've done that, we'll see that both of those terms on the right-hand side have a sorry about that. Both of those terms on the right-hand side have a T1 in them, which means I can pull out a T1, making the left-hand side, or leaving the left-hand side the same. And on the right-hand side, we would have a T1 times the quantity V1 minus V average. All right, we're almost there, dividing both sides by that right-hand parenthesis term we have here. And this is our final equation that is going to tell us what T1 is equal to. Substituting in our values from above, we have 2.46. But that's not the final answer, although some of you, I think, stopped that way. We need the total time, so we need to add in that 22 minutes that she was stopped. In doing so, right, that's your 2.46 we just found, times the 3.7. I really should have units on that, my bad. So we get 2.83 hours, put a box around it, and you are done.